Can you kind of break it into simpler terms? What is lactate for people who don't even know what we're talking about why you even care about a threshold?
Sure, sure. Well, we have three energy systems, just metabolic systems in our body that would produce energy. And that energy, from a biological standpoint, is called ATP. So when you split ATP apart, that releases energy. And most of that is lost as heat, which is the calories. When someone says they're burning calories,
Yeah.
that's essentially what we're measuring, is that heat loss. But we're able to harness some of that energy for mechanical work, and that would be running or riding or whatever. So you've got these three energy systems that can make ATP. Two of them are anaerobic, meaning that you can create energy without having to use oxygen, and one of them is aerobic, and you obviously need to use oxygen for that. The max rate of that oxidative system or energy system is what we call Vo2 Max or Vo2 peak. Okay? So that means that we have to start looking at these other curves. What's their role? They can produce energy much, much faster, but they're confined by certain limitations. One of them, for instance, if you were just sprinting for 100 meters, you're only going to have enough fuel to supply that energy system for maybe 10 to 15 seconds. And then that's when you have to shut down, walk, replenish that system, and you can replenish it really quickly. But that's, those kinds of intervals aren't really beneficial for an endurance athlete, right? A 10 to 15 second thing, that might be helpful for a workout, but not necessarily for any performance they're going to do. So then we look at the next energy system, which is called the glycolytic system. Sometimes it's known as the lactic acid system. And that's where you use carbohydrates. You break those down through a process, and you're going to end up with this fancy little molecule called pyruvate. Pyruvate then can go one of two places. It can either get shuttled into the mitochondria of a cell. That's where all the oxygen processing happens, or it can get turned into lactate. Now, there's bottlenecks on these mitochondria, and they can only accept pyruvate at a certain rate. So if you're exercising at an intensity that's high enough that the mitochondria can't accept all that pyruvate, then the pyruvate is just going to be hanging out, and at that point in time, it gets turned into lactate. So at this point, it's probably important to say or dispel a few myths that have been out for a long time, and for good reason. It used to be that people thought lactate was the problem. Lactate was this precursor for fatigue and all that, because they'd see people fatigue in the lab and they'd see, wow, lactate concentrations in the blood are really, really high. This must be the problem. Now we actually know that lactate is a friend, not a foe. It's actually really, really helpful. It's just a marker for the fatigue. What the problem is when you convert pyruvate to lactate, you go through this transition phase where it becomes lactic acid, so it's pyruvate to lactic acid to lactate. That conversion from lactic acid to lactate releases protons into a cell, a muscle fiber, and those are very acidic. And every aspect of our body is designed to work within a certain pH tolerance. So when you start putting a bunch of acidic things in a muscle cell, it starts to shut down all of the systems that are designed to work within a certain pH. If you go below that, they just don't want to work. So to try and keep things on the up and up, the muscle cell will export the lactate and the protons into the blood. And at that point, the muscle cell can still function, but now you've just kind of robbed Peter to pay Paul. You've taken this acidic substance and put it into the bloodstream. And so that's going to have some consequences in terms of how you breathe. And of course, that's how we're able to measure the blood lactate, is we just look at what the lactate concentrations are. And there's an implication then, okay, that means the blood is also really acidic, and it also means some active muscles are creating a lot of this lactate and they're pumping it out to the system. Lactate threshold then basically just implies what is the point, like the max point that a muscle will reach where lactate production equals lactate export. So as soon as you're creating this lactate and the associated protons that are going to cause all these problems, what's the point where you can't get rid of them as fast as they're being produced? And when you start to go beyond that point, that's when you start to get an acidic environment building up in the cells, and that's what's shutting you down, even though the lactate is just kind of hanging out and not necessarily causing a problem.